Hello and welcome back to the Stephen Mendes channel and our continuing series on programming the Yamaha DX synthesizer. As you can see, the beautiful DX27 synthesizer is here beckoning to us this afternoon. And what I'm going to do with you, I'm going to carry you through two patches. One is the electric piano patch, which is a factory preset, and programming information was requested by a viewer, and the other one is a totally original patch that I created myself. I've copied the electric piano patch into programmable memory location 4 so that we can go into the edit mode. Once we go into the edit mode, we can see all the parameters that it has. What's more, we can turn on and off the operators and see their effect on the sound. To do that, you press the Edit Compare button. Let's see what algorithm it uses by pressing the Algorithm button. We see on our display that it uses Algorithm 5 and that all the operators are turned on. Let's go and see what Algorithm 5 looks like. As you can see, Algorithm 5 is 2 stacks. So we have only the 4 operators separated into 2 stacks. And the only carriers are therefore 1 and 3. So let's go and see what the levels are set at. We can take a look by pressing on the operator output level button, and then we come over here and we see that operator 1 is set to an output level of 95. We can scan through the operator levels by pressing the operator select button over here. There we have it. Each press of the button carries our operator to a different one. So we see that operator 2 is set to output level 78, operator 3 is output level 95, and operator 4 is output level 32. Let's turn off our operators one by one and see what effect they have on the sound. As you can see, we have the 4 operators on and off buttons here, 1, 2, 3, 4. And we can tell whether they're on or off by looking at those 1s in the display. So we're going to turn off the 2 carriers one after another. So as we saw in Algorithm 5, we have carriers 1 and 3. So let's turn off 3, shall we? So we press on the 3 button and we see that the 3rd operator has gone to a 0. So now the sound will have changed. Let's turn it back on. As you can see, it refines the sound by adding that time to it. Let's see what happens if we do the reverse. We turn on operator 3 and turn off operator 1. Okay, so now we're looking at the other side of the stack. Turning it back on. So our electric piano voice is the combination of those 2 sounds. That's exactly what it is. The combination of those 2 sounds. Now let's see what effect the modulators have on the sounds. In the case of carrier 1, we have a pure sine wave tone and nothing more. In the case of carrier 3, it's also a sine wave with a slightly percussive attack. Slightly percussive attack on operator 3. But as we would expect, both operators without any modulation produce sine waves. As you can see, the piano voice uses a maximum feedback level on operator 4. Remember, my friends, other than the actual output level, the other most important parameter is ratio. The ratio of your operators. Now, operator 1 has a ratio of 1, which means it conforms to the standard keyboard pitch. Operator 2 has a ratio of 1. Operator 3, but notice operator 4 has a ratio of 12.11. Fractional operator ratios tend to produce bell-like percussive sounds. And notice the tine sound of our operator stack, the 3 and 4, produces the tine sound. We let you hear it once again. Now you might wonder, my friends, what is the effect upon the overall piano sound of changing the level of operator 4 in the tine sound? Notice that it's set to 32 there, and that's the regular sound. If we reduce it, as you can see, we don't want it too low because there's no tine, or if we set it too high it becomes all tine, and so the level of 32 presumably was chosen by the programmers as producing a lovely electric piano, and it is actually one of my favorite voices in the DX27. Let's take a look at a patch which I created from scratch now called Data Sound. It produces that sound so famous in science fiction movies. And if you hold a high key, it's in the upper register, and if you hold a low key, it's in the lower register. How do you think that gets done? Well, you need to familiarize yourself with the sample and hold function, which is a function of the low frequency oscillator, and in this particular synthesizer it works quite well. For that particular voice I'm using algorithm 4, but it really doesn't matter because I've got all my modulators turned off. Therefore I could have used any of the algorithms from 1 to 4 as long as I turned off all operators except the carrier, which is 1. And to prove that to you, I'm going to go here and I'm going to touch the output level, operator output level here, and then I'm going to just go between them, and you'll see that operator 1 is the only one that's active at maximum level of 99. Okay? So really I'm operating on just with operator 1. And I'm using a feedback ratio, a frequency ratio of 0.5, which means, all that means is really that it's operating an octave. I've shifted the keyboard by an octave by using 0.5 as my frequency ratio. It wouldn't matter what I had the feedback level set to, because that's not going to work with this algorithm, because the output of that operator, the one that has the feedback, is turned off. You select the sample and hold by going to the LFO waveform button. See where it says LFO wave? You press that and you notice that you have a number of choices, and S hold has been selected. Other choices are saw, up, square, triangle. Okay, so we leave it at sample and hold. And what else do we need to set? We need to set the speed, which we have set to 39. The last thing we need to set to get our data sound is to have maximum pitch modulation. In order to use the sample and hold function to modulate the pitch to its maximum value, there are two settings you have to do. One is the PMD setting. That's for pulse, pitch modulation, sorry, not pulse, pitch modulation there. And you set that to the maximum number of 99. And finally you set your pitch modulation sensitivity here. Note it says modulation sensitivity pitch. The maximum value of the pitch modulation sensitivity is 7. So those are all you have to do to get your data sound, and you can use practically any algorithm, any single stack algorithm. So that's just been a short, quick video to show you the wonderful sonic possibilities, and it can all be done from the front panel with only a few buttons. So go out and get your DX27 today and you won't regret it. Many sonic possibilities await you. Thank you for joining us at 21st Century Music, and for watching our host channel, Stephen Mendes. Thank you so much. And we'll see you soon again.